Hey guys, in this video I'm going to show you how to do stoichiometry going from mass to mass. Let's look at this first sample problem. This sample problem talks about how we have 2 moles of potassium chlorate will become 2 moles of potassium chloride and 3 moles of oxygen gas. And we have a question asking how many moles of oxygen gas can be produced by letting 20 moles of potassium chlorate react. I know this might sound like a lot of jargon, but let's break it down into little baby steps, and this should be pretty easy to manage. The first question that we should have is what's the given? All right, let's look for the given, and the given is right here. Right here is our given unit and value. So let's start with 20.00 moles of potassium chlorate, right? KClO3. It wants to, this problem wants us to convert from potassium chlorate, KClO3, to O2, from potassium chlorate to O2. When we switch from one chemical to the other, we rely on a balanced chemical equation, which is provided up here. And by looking at this chemical equation, you can see that for every 2 potassium chlorates, there are 3 oxygens. Right? Let me show you. Right, for every 2 potassium chlorates, there are 3 oxygens. So, to get out of moles of potassium chlorate, let's put moles of potassium chlorate on the bottom. And then let's put oxygen on top, right? We want to go to moles of oxygen, right? This chemical equation is talking about moving from moles to moles. That's just what a balanced equation looks like. So, and all we got to do is put the coefficients in front here. So 2 potassium chlorate and 3 oxygens, right? I got these numbers right up here, right? I just got them from the balanced chemical equation. So all of a sudden we're no longer in potassium chlorate. This cancels out. And now we're in oxygen. So we just have to type in 20 times 3 divided by 2. And I got 30 moles of oxygen. Pretty easy. All right. Let's try another one. How many moles of hydrogen gas, H2, are necessary to completely react with 15 moles of nitrogen gas? So our given is 15 moles of nitrogen gas. Notice that I include both the units and the chemical along with the value. A lot of us might be a little lazy and just want to put in the value, but don't forget both the chemical and the unit. It's going to help us in the next couple of problems. So to get out of N2 gas, let's get out of moles of N2, put it on the bottom so they will cancel, right? And this problem wants us to go into hydrogen gas, so let's move into moles of hydrogen gas. Fine. And if you look here, for every 1 nitrogen gas, there are 3 hydrogens. For every 1 nitrogen, there are 3 hydrogens. Again, in this conversion unit, I use the chemical equation right up here. Right, I use that chemical equation. So this becomes pretty simple. 15 times 3 divided by 1. And I got 45 moles of hydrogen gas, right? Because these things cancel. The only units left are moles of hydrogen gas. So we just transfer it all the way over here, and we're good to go. So it's basically the same procedure of dimensional analysis that we talked about in the past, where if we want to get out of a unit, we put it on the bottom of the conversion factor, and the unit that we want to get into, we put it into the top of the conversion factor. Fine. These things are simple. Let's go to some more complicated ones. Here, we're not in moles this time, we're in grams. Grams of potassium chloride, and it wants grams of potassium chloride given grams of potassium chlorate. So we can't use the chemical equation yet. The chemical equation is written in moles. It's written in numbers of atoms or molecules and counts in moles. And right now we are given grams. So that's no good. So the first thing we should do is we should convert to moles. So let's start with our given. 35.0 grams of potassium chlorate, KClO3. Let's get out of grams and into moles. Why? So that we can use this chemical equation. The very first step is to convert to moles. So let's get out of grams of potassium chlorate. And let's go into moles of potassium chlorate, KClO3. And this step might seem a little bit goofy to you, but I know that 1 mole of potassium chlorate weighs 122.55 grams. How did I do that? Well, I added up all of these molar masses. There's 1 potassium, there's 1 chlorine, and there's 3 oxygens. If you need some extra help, you could look up my other video about finding the molar mass of compounds. But here's the molar mass. I know that 1 mole of potassium chlorate weighs 122.55 grams. Great, that gets us out of grams. And now that we're in moles, we could do the same procedure that we just did, meaning I can go from one chemical to the other using the chemical equation. So let's go out of moles of KClO. Oops, KCl. Ugh. Let me just erase this because it's ugly. Get out of here, you. Yeah. Okay. All right. Potassium chlorate. Better. All right. And let's get into the moles of the chemical the problem wants. The problem wants the potassium chloride. So let's get to potassium chloride, right? Here, for every 2 potassium chloride, there are 2 potassium chlorides. Well, okay, that's a 1-to-1 ratio. 2 to 2. Fine. So we're no longer in moles of potassium chlorate. We're now in moles of potassium chloride. But the problem does not want moles. The problem wants grams. The problem wants grams. So let's get out of moles and into grams. I think many of us know what to do here. Put moles on the bottom, moles of KCl. Let's go into grams of KCl. And for every 1 gram, I'm going to again do the procedure of finding molar mass. And doing a little math ahead of time, I know that there are 74.55 grams for every 1 mole of potassium chloride. Fine. So let's do a little bit of math. And I got 21.3 grams of potassium chloride. Good. Here, let's review what I did in this problem. Let's get rid of all of this junk. Get out of here. Yeah. It's very satisfying to see all that stuff disappear. Okay, so the very first step here, this first step, I converted to moles. Alright, why did I convert to moles? Because it's the only way to use this chemical equation. If I want to change from one chemical to the other, I have to use this chemical equation, and this chemical equation describes moles. It describes molecules, counts, atoms. It doesn't describe grams or volume. It describes actual individual molecules. So I gotta first convert to moles. From there, here, as you can see, I have a mole-mole thing going on here. Here I am changing the chemical by using the chemical equation. And then finally, in the very last step, what I'm doing here is I am converting to the unit that it wants. So here I was converting to grams, right? Fine. But just know to first you gotta convert to moles, then you can change the chemical, right? Let's try a few more problems. Here, how many grams of sodium hydroxide is produced from 2.8 times 10 to the second power grams of sodium oxide, Na2O? Don't let the exponent scare you, right? This just means that we got to move the decimal 2 times over, 1, 2. So it's just 280 grams of sodium oxide. So 280 grams of sodium oxide, Na2O. So if you recall, the very first step is to convert to moles. Let's get out of grams. Let's get out of grams of Na2O and into moles of Na2O. I know that every 1 mole, right, the 1 and the molar, they're kind of married together, is equal to 61.98 grams. Where did I get that funky number? Well, there are 2 sodiums, so 22 point, so like 23 and 23, that's like 46 plus another 16 is like 62-ish, right? So here's 61.98. I was just adding up the molar masses. So now that we're out of grams of sodium oxide, I can convert the chemical. We're now in moles, and this problem wants moles of sodium hydroxide, NaOH. So let's get out of Na2O and into NaOH, right? These are in moles. So looking at the balanced equation, there is 1 mole of Na2O for every 2 moles of sodium hydroxide. For sodium hydroxide, there are 2. And for the Na2O, there's only 1, right? A 2-to-1 ratio that I got from the balanced chemical equation. I am no longer in moles of Na2O. I am now in moles of NaOH. But the problem does not want moles of NaOH. It wants grams of NaOH. So let's put moles on the bottom. Moles of NaOH on the bottom, right? And let's get into grams of NaOH. That means I just have to add up these 3 masses. I know that 1 mole of NaOH is 39.997 grams of NaOH. Alright, that takes us out of moles of NaOH and into grams of NaOH. And then now with a little bit of math, I'm going to punch this through, and I get 361 grams of NaOH. Don't forget what we did first. First, we convert to moles. Right? That was our first step, convert to moles. And then we use the molar ratio from the chemical equation to switch the chemical. Then I used the chemical equation. Okay, let's do one last sample. Hopefully you guys are getting the hang of it. One last one. How many grams of magnesium oxide is produced from 1 gram of magnesium? This is basically our the lab that we did where we burned that little strip of metal, right? Our given is 1.00 grams of magnesium. You should know by now the very first step is to convert to moles. So let's get out of grams of magnesium and into moles of magnesium. Right? For every 1 mole of magnesium, there are 24.3 grams of magnesium. And let's get out of grams. Let's convert the moles. Right? Let's go from moles of magnesium to moles of magnesium oxide. All right. And looking at the equation, it's a 2 to 2 ratio. 2 to 2. And then finally, let's get out of moles of magnesium oxide, all right, and into grams of magnesium oxide. And I know that 1 mole of magnesium oxide weighs around 40.304. So when I do all this math, I get 1.66 grams of magnesium oxide. Okay, so in review, the most important thing is to convert to moles first. Convert to moles. Once you're there, you can use the chemical equation that says chemical equation. And then from then on, you can convert to whatever you want. But really, for reals, first thing you got to do is convert to moles. Hope this helps out. And yeah, thanks for watching.